Welcome to our calculation on chemistry continuation. We are looking at calculations under Gay-Lussac's law. Okay. If you need anything, any material, any notes, if you need the most repeated question by JAMB, you can send me a message on WhatsApp. Or you want me to coach you for the exam, here is my WhatsApp number. Do well to send me a message so that I will be able to help you. All right. Now, let's look at the question we have in front of us here. JAMB must repeat question under Gay-Lussac's law. The question reads, 20 cubic centimeter of hydrogen gas are packed with 20 cubic centimeter of oxygen gas. Calculate the volume of the residual gas after the reaction. What is Gay-Lussac's law? They say we should calculate the volume of the residual gas after the reaction. What is Gay-Lussac's law? Gay-Lussac's law states that when gases react, they do so in whole numbers. Okay? Gay-Lussac's law. It states that gases combine. Okay, gases combine in what? In whole number. So when gases react or when they combine, they do so in what? Whole number. Okay, whole number what? Ratio. They do so in whole number what? Ratio. Alright, let's put whole number ratio. Alright, so when gases react, they do so in whole number ratios. Alright, so you don't have 1/2 oxygen, half oxygen molecule. No, you must round it up to a whole number. This is how you leave it as oxygen molecule. So the first thing to do in such question is you balance the equation because you are going to need ratio. Alright, balancing the equation says 20 cubic centimeter of hydrogen gas. So hydrogen gas reacts with oxygen gas. Hydrogen gas plus oxygen gas gives you what? Water. Alright. First of all, is this equation balanced? No, it's not balanced because we have 2 hydrogen here and we have 2 oxygen here. Okay? There's 2 oxygen here. Yes, we have only 1 molecule of oxygen. So what do we have to do? We have to balance the equation. If I put 2 here now, for example, it's going to be 2 times 2, 4. That's why we're going to have 4 hydrogen atoms. Alright? And here we still have 2 hydrogen atoms. If I add 2 here, it's going to be 2 times 2, 4 hydrogen atoms. And it's also going to be 2 times 2, 4 oxygen, 2 oxygen atoms. So 2 is going to work. If I put 2 here, and I will also put 2 here. So this one makes it what? 4 hydrogen atoms. This one makes it 4 hydrogen atoms too. And this one makes it what? 2 oxygen atoms plus these 2 oxygen atoms. Balances with the left and right. Is balanced. Alright? So what do you have to do? We can identify the ratio next. The ratio of the volume. Okay? The volume here is 2 ratio. How many of oxygen? 1. That's the ratio is 2:1. It gives how many volume of water? It gives 2 volume of water. But we don't need this one. It's only the reactant side now we need. So therefore, 20 cubic centimeters of H2, which is hydrogen, needs how many? 10 cubic centimeters of what? Of oxygen to form 20 cubic centimeters of H2O. So 20 cubic centimeters of hydrogen needs 10 cubic centimeters of oxygen to yield what? To yield 20 cubic centimeters of water. Now, we have to understand what is called limiting and excess. Alright? Limiting and excess. So, this is the time to find limiting. To find what? Limiting and excess. Limiting is the one that is completely used up. So, limiting means completely used up. Okay, completely used. Let's put it like that. Or completely used up. But excess is the one that is what is like a remainder. Remainder. Okay, it's like a remainder. After the reaction, it's remaining. It wasn't used. Okay, so let's now find it in this reaction. Okay, limiting and excess. All right. In this reaction here, hydrogen gas, 20 cubic centimeter. According to the question now, 20 cubic centimeter of hydrogen gas. Let's look at the reaction. Was all the 20 cubic centimeter of hydrogen gas used up during the reaction? Was all of them used up during the reaction? Remember, 20 cubic centimeter of hydrogen reacts with 10 cubic centimeter of oxygen to form 20 cubic centimeter of water. Was all the 20 cubic centimeter of hydrogen used up? Yes. All used up. All used up. All used up. Used. Okay. Which makes it what? Makes it what? Limiting. Okay. So all used up. That's why it's limiting. Therefore, oxygen. Okay. For oxygen, O2. Remember, the question says 20 cubic centimeter of hydrogen gas as packed with 20 of the same oxygen gas. Calculate the volume of residual gas after the reaction. After the reaction, if you look at this one now, according to the ratio from the Lussac'S law, it's telling us that it's only 1%. I say 1%. It's only half. Okay, it's 2 now. 20 is 2. That tells us that it's 10. It's only half of oxygen that was used. So that means it's 10 out of the what? The 20 cubic centimeter of the oxygen provided. It's only 10 that was used. Okay, so 20 cubic centimeter is available, but inside this 20 cubic centimeter available, only 10 cubic centimeter was used. So we have excess of, therefore we have excess of what? 10 cubic centimeter of oxygen atom. Okay, we have excess of 10 cubic centimeter of oxygen gas or oxygen atom. All right, so that shows that this one is the what? The excess. So what does that mean? It's very easy. So the excess oxygen is equal to 10 cubic centimeters, as simple as ABCD. So easy. If you understood what I've taught you properly, you should know that after getting this, after balancing the equation, you've gotten the answer to this question. After balancing the equation, you've gotten the answer to the question. Remember, it asks us to calculate the volume of the residual gas. That's the gas will remain. It is this excess that is the residual gas. The gas will remain after the reaction occurred. So this one is the volume of the gas left. If they ask you to calculate the mole of the gas left, it's not going to be what? You're not going to use mole now to calculate it. Mole is equal to mass time, but mass wasn't provided here. So they will hardly ask more for this kind of thing. But what they ask now, volume of gas left after the reaction. That's the gas remaining. So immediately as you balance this equation, you already know the answer to this question. I'm telling you. Immediately after balancing the equation, you should know the answer. So I just all this one for story, make it for make you understand well. Make you understand what limiting and excess mean. You have to know that. Very, very important. Very, very important. So among the option, pick the correct answer and drop it in the comment section. Let's move on to the next. JAMB 2026 candidate, welcome. Today we are looking at Graham's law of diffusion, all the calculations under Graham's law of diffusion. If you want me to coach you for this JAMB UTME, please send me a message on WhatsApp. You want any material, the most repeated questions in JAMB UTME. I also have the file. Okay, I have the file of the selected topics where JAMB is going to set calculation questions from. That's what we are treating here, the high need. Okay, I also have that file. My short lesson notes available in physics, chemistry, biology, also available in English too. Everything there. So send me a message. I'm all you need to pass. So send me a message. There you go. The question we have under Graham's law of diffusion is the rate of diffusion of a gas X and Y are 3:1. He says what? Is 3:1. Okay, this is for what? For S, and this is for Y. All right, respectively. That's why we just quickly put up, make we no mistake. Calculate the ratio of the molar masses. Calculate the ratio of the what? The molar masses. Why are we using Graham's law of diffusion here? Because the Graham's law of diffusion, Graham's law of diffusion. You know the meaning of diffusion now? When gases moves from it can be gas, it can be particle. Okay, moves from a region of a higher concentration to the region of a lower concentration. So the law of Graham's law of diffusion says that the rate of diffusion of a gas is equal to the square root of its vapor density. The square of its vapor density. That's the law. And you can see that they are asking us what's the ratio of S and Y respectively. So that's why we have to, since we are talking about diffusion of gas, is Graham's law of diffusion that you are going to use. And it's given by R1 over R2 square root M2 over M1. As easy as ABCD Shikina. What were we giving? We were giving ratio 3:1 ratio respectively. Okay, 3:1. What were we giving again? The ratio of S gas is equal to 3. The ratio of Y gas is equal to 1. Now all these things they give us the same. So the same will find we can calculate the ratio of their molar mass. So the ratio of their molar mass, or the ratio of their molar masses, which is this, what was it called? Molar masses MS and MY equal to question mark. All right, so this is what we are looking for. All right, so we have to apply this formula. But before we apply this formula, let me quickly tell you what some stuff in the formula stands for. R is equal to what? Rate of diffusion. Know that Graham's law of diffusion is talking about the rate of diffusion of a gas or of a substance, but most of the time now gas. All right, rate of diffusion. M, this capital letter M, equal to molar mass. Anywhere where you see them, okay, equal to molar mass. Okay, so all this ones are molar mass 1, molar mass 2. Rate of diffusion 1, rate of diffusion 2. And this thing where you see for here, so now the ratio. This rate of diffusion is represented as what? The ratio. Okay, the ratio. All right, so you can see it as rate of diffusion or the ratio of diffusion. This is ratio. So what do? We substitute everything and solve. All right, given the formula we already know that all this one are molar masses. All right, so we substitute R1 now waiting. R1. That's the first ratio is 3. Okay, 3. Then R2 now waiting. The second ratio for Y over 1. Okay, then equal to square root. Okay, this one carry equal to, now the formula with this equal to square root of M. We're going to replace them with M2. Now waiting be M2. The gas 2 now waiting Y. So waiting we're going to get here now MY over gas 1 M waiting MS. All right, now this thing now we get. So for mass, if you get this kind of thing, how you want this over? That's where your basic mathematical knowledge comes into play. You square both sides. Okay, let me just write it for you. Square both sides. Okay, square both sides. It's just like turning this thing to squares so that you can remove this root. Okay, so you're now going to have 3 raised to power 2 over 1 raised to power 2 equal to root. No, not root again. No. Which one be root again? Equal to, that's why you have to be very, very careful. M, because the essence is to remove this square root. MS. How we say we get numbers inside here now? We will just solve the numbers, find the square roots. No need to be square both sides. But here, because they are letters, we have to square both sides so that we can solve and cross multiply if need be. Alright? 3 times 3 now waiting 9 over waiting we get here 1 times 1 now waiting 1 equal to my over mx. So that one don't already give you the ratio now. It means say 9 now the ratio of what? The gas y. 1 now the ratio of what? The gas s. Easy as A, B, C, D. So to find molar ratio, my is equal to 9. ms is equal to 1. So the molar ratio of s to y is what? The molar ratio is equal to what? ms ratio my is equal to 1 ratio 9. So among the options, pick the correct option and drop the answer in the comment section. Let's move on to the next.